Hi everyone, in this video we are reviewing Unit 6. If you haven't already, please make sure that you are trying this on your own. That's the whole purpose, is that you try it on your own and then watch the video to check and see if you did it correctly. So just make sure that you've tried it already on your own. Okay, so with this first question, we are given a rectangle and it is asking what the area is of the rectangle. Well, thankfully it tells us that area is length times width. So let's call this guy on the bottom our length and then this on the side our width. And now we're going to need to multiply, and we know how to multiply with exponents. So we're multiplying 3xy squared times 2x squared y cubed. Okay, so I'm going to color code these. So our coefficients, we're just multiplying the numbers. We get 6. Then our x's, we are going to add the exponents. So this guy on the left has an exponent of 1, and 1 plus 2 is 3, so we're going to have x to the third. And then our last one, I'm going to do in blue. So y squared and y cubed, 2 plus 3 gives me 5, so y to the 5th power. So this is the area of that rectangle. Okay, so for number 2, it's very similar to the first one, except it doesn't have a rectangle. So let's first multiply the coefficients. That gives us 8. Then let's multiply the a's. That will give us a cubed. And then let's multiply the b's, and that will also give us, that'll give us b cubed. So there is the simplified version. Okay, so with number 3, it has some negative exponents. We're going to work with those after we multiply each of the like terms. So let's multiply first. So 3 times negative 2 gives me negative 6. X to the negative second and x to the first, we are adding, so this is going to be x to the negative first. And then lastly, we have y, and we have y to the negative third, so that's going to give me y to the negative second. Okay, so what we're going to do is our numbers with our variables with negative exponents, in order to make them happy, we need to, in order to make their exponent positive, we need to move them to the bottom. So our negative 6 is going to stay on top because it does not have a negative exponent. It is a negative 6, however, its exponent is still 1. And in the denominator, we're going to have x to the first power and y to the second power. And the best way to write this is to not write that first power for the x because it is not necessary. So you should just have in the denominator x and then y to the second. Okay, so now we're going to work with number 4. And with number 4, we have a negative exponent in the denominator. So the first thing I want you to do, if you, hopefully you did this, is you moved that z to the negative 7th to the numerator. So our new numerator should be 22 y to the 6th, z to the 8th, and then z to the positive 7th. And then in the denominator, you should have 2 and you should have y. Okay, let's clean this up a little bit. So let's first combine our z's. So we're going to add those exponents. So 8 plus 7 is going to give me 15. So we're going to have z to the 15th. And then if I am dividing variables with exponents, I'm going to subtract. So I'm going to have my remaining y's in the numerator, and I'm going to have 5 y's. So I'm going to write y to the 5th. I'm not going to have any y's in my denominator. And then I can divide 22 by 2. That'll give me 11. So I no longer have a denominator, or my denominator is 1, I should say. So this is the most simplified version. Alright guys, so now we are on the second page of this review. We have a power to a power and that's the first thing that we need to do. So whenever we have a power to a power, we're going to give that to each term that is in the numerator and each term that is in the denominator as well. So when we do that, we get 3 to the 5th. We are going to multiply our exponents. So we are going to have m to the 10th. Then we are going to multiply our exponent with n. So 7 times 5 gives me 35. And then we are going to give it to the m and the denominator. So 3 to the power of 5 gives me 243. And the last thing that I can do to simplify this fraction is I can divide my m's. And so when we are dividing, with our exponents, what we're going to do is subtract. And whatever our remainder is, it's going to stay in the spot in which it was. So for example, 10 minus 5 is 5, and since 10 was the bigger number, it's going to, the 5 remaining is going to stay in the numerator. So I have 243. I do not have a denominator, and I have n to the 35th power. And that's it. That's my answer. Alright guys, so let's go ahead and move on to number 6. So let's work with the numerator, and then we'll work with the denominator, and then we'll simplify that way. So let's first do negative 12 times positive 5, which is going to give me negative 60. And then let's do x times x to the 6th. So whenever we multiply exponents, we're actually going to add them. So we're going to have x to the 7th. And then y squared times y to the 3rd. So that's going to be y to the 5th. All right, now let's do our denominator. Negative 4 times 15 is going to give me negative 60. X times x squared is going to give me x to the 3rd. And then y times y is going to give me y to the 2nd. Okay, so this negative 60 over negative 60, that is equivalent to 1. So we can essentially just like erase them because we don't need to write it since we're multiplying. So we don't need to write those. With the x's, we have x to the 7th and x to the 3rd. So we're going to subtract, and our remainder is going to be in our numerator. So we're going to have x to the 4th in our numerator. And then with our y's, we have y to the 5th and y to the 2nd. So we have a remainder of y to the 3rd, and that is in our numerator. Okay, we can simplify one last time, and that's getting rid of that 1 in the denominator. So our answer is x to the 4th and y to the 3rd. Okay, so number 7. So the largest perfect square that goes into 200 is 100. So the square root of 100 times the square root of 2 gives us the square root of 200. We can rewrite this as, we can take 100 out of the radical sign, and it becomes 10. And then inside, we have that 2. Right, now let's look at our variables. So we can only take variables out in groups of 2. So since we have m to the 4th power, that means we have 2 groups of 2. So we can take that out and rewrite it as 10 to m to the 2nd square root of 2n, because we had 4 m's and they created 2 groups of 2 m's. And that is our simplified answer. The last one on this page is number 8. So let's first simplify this 24. 4 times 6 gives me 24, and 4 is a perfect square. So when I take 4 out of the radical sign, it becomes a 2, and I leave 6 inside. Negative 3 times 2 gives me negative 6 on the outside. And then, guys, let's take care of those variables inside. So I can only take them out in groups of 2. So that means that on the outside, I'm going to have a squared. I'm just going to have a b. I'm not going to have a b on the inside. And then I'm also just going to have one c because I only have one group of 2. However, I'm going to have a remaining 2, or I'm going to have a remaining c because I have a total of 3 c's. So I'm going to have a remaining c inside of the radical. Okay, so now we are on the back. We're on number 9. This is our first question with a cube root. So with cube roots, we can have a negative inside of the radical sign because when you're cubing something, you're multiplying it 3 times. When we multiply something 3 times, we can get a negative answer. So for example, negative 2 times negative 2 times negative 2 is going to give me a negative 8. Okay, so this works anytime when you're multiplying something an odd amount of times. So inside the radical sign, we have negative 56. We need to think of perfect cubes. So 2 cubed gives me 8. Let me see if 8 can be divided by 56. It can. 3 cubed is 27. Let's see if 56 can be divided by 27. It cannot. 4 cubed is 64. Okay, so I guess we're going to have to work with 8. So what I want you to do is make sure when you draw your radical sign that you put the little 3 since we're dealing with cube. So since we know that 8 times 7 gives us 56, I want you to make sure that when you write this 8, you put a negative in front of it because that's our perfect cube. Okay, we can take this negative 8 outside of the radical sign, and when we do, it becomes a negative 2. So then inside the radical sign, we have a 7, and don't forget to write your index, your 3. There we go. Okay, so whenever we are adding or subtracting radicals, we have to first simplify, because when we add or subtract, the radicand, so the number inside of the radical sign, has to be the same. So it's kind of like fractions, if you think about it. Your denominator needs to be the same. So let's first simplify this square root of 12. So we know that 4 times 3 gives me 12. 4 is a perfect square. We can take it outside of the radical sign. It becomes 2. I got to multiply it with that coefficient. So now we have 4 square root of 3. Okay, that is not my answer. I know I circled it. But that's because I'm going to rewrite it, because now we are going to be able to add. So let's rewrite this as 4 square root of 3 plus 3 square root of 3. All right, we're going to add the coefficients. 4 plus 3 is 7. And then we're just going to write the square root of 3. And there we go. Okay, so number 11. So we are multiplying, and whenever we're multiplying, we're going to first multiply the radicands and then see if we can simplify. So we're going to do 15 times 10, which gives me 150. So that's our radicand. And then make sure to write your index. So with this one, let's see if there are any perfect cubes that we can divide 150 by. So we know that 6 cubed is going to give us 216, so that's too big. We can't divide. 5 cubed is 125. We can't divide 150 by 125. 4 cubed is 64. We can't divide 150 by 64. 3 cubed is 27. We can't divide 150 by 27. 2 cubed is 8, and we can't divide 150 by 8. So in this case, this is the most simplified version. This won't happen very often. Most of the time, you can simplify the radicand. However, I do want you to know that don't feel like your answer is wrong if this ever happens, because it does happen. Okay, so for this last one, there is a typo. So you need to change the 45 and the radical sign to a 48. This should be correct on your document. If it's not, just change it and now try it on your own. But it should be 48 inside of the last radical sign. Okay, so with adding and subtracting, we need to simplify first. So let's see if we can simplify this 27. I know that 9 times 3 gives me 27. 9 is a perfect square. I can take it outside of the radical sign. When I do, it becomes a 3. Let's bring this 4 down. And then inside the radical sign, we have 3. 4 times 3 gives me 12, and then I have radical 3. All right, let's simplify that 48. So 48 can be divided by 16. 16 times 3 gives me 48. 16 is a perfect square, so when I take it out of the radical sign, it becomes 4. And the radical sign is 3. I'm going to bring this negative 4 down. Negative 4 times 4 gives me negative 16, and in the radical sign, I have 3. So as you can see, with each of these, I have the same radicand. So we are going to be adding, and then we're going to be subtracting. We're going to follow order of operations, so we are going to go from left to right. So 3 plus 12 gives me 15 square root of 3. And then I have 15 minus 16, which is going to give me negative 1, which I don't need to write the 1, negative square root of 3. So that is my answer. All right, good job, guys. Thanks for watching this video. Good luck on the test.